Hi everyone, welcome. Today we're going to be deconstructing one of the most significant engineering challenges of our time. We're going to be talking about bias in artificial intelligence. Now, I want to be clear about my perspective here. I'm not a sociology professor, I'm an engineering professor, okay? So, my goal is not to teach you the social theory of fairness, that's definitely not my domain. I'm here to demonstrate the mechanical reality of how gender bias sneaks into AI through our engineering solutions. We're going to look at how these systems are actually built, the specific failure points in the code, and how we, as the people who define the architecture, who consume the architecture, can engineer better outcomes. Let me tell you something that might sound a little uncomfortable. If you build AI systems, you're already shaping social outcomes. Not in the hypothetical level, not in the philosophical level, but I'm talking about the mechanical level, the technical level. Research shows that the technology is a product of its time and organizational context. What does it mean? It reflects the knowledge, the materials, and the implicit biases of its creators. So when we deploy an algorithm, we aren't just shipping the code, right? We're shipping a sociotechnical blueprint. This is not just a technical determinism where the machine dictates our future. It's about the fact that the design choices we make in the lab become the automated laws of the outside world. So today we're going to be breaking down exactly how that happens and why you should care. Actually, let me start with why you should care about AI bias. You may be thinking, I don't work in AI, I'm not an engineer, why should I care? Let me make this very simple for you. AI systems are already making or influencing decisions about who gets hired, what kind of jobs you even see when you're in the job portal, what content you consume on social media, what loans you are qualified for, what medical risks are flagged, what opportunities reach you. So AI quietly shapes opportunities. Most people think decisions are still made by humans, but they're not. Think about it for a second. They are filtered by systems first. Before a recruiter sees your resume, an algorithm may decide whether you're even worth seeing. Before you see a job posting, an algorithm may decide whether you're a good fit. So the real question is, what patterns is that system using to decide? If those patterns reflect bias, then opportunities are not distributed fairly. And most people never even realize what kind of opportunities they're actually missing. Another reason why being aware of these biases in AI is important is because bias in AI is invisible. Human bias is often visible. You can question a human bias, you can challenge a human bias, you can confront a human bias, right? But AI bias is sneaky. AI bias is different. It is hidden. It is hidden in the algorithms embedded in the data. It is justified as objective that the model needs to optimize. And the third reason why you should care about bias is AI scales small biases into large impact. So what do I mean by that? A single human making a biased decision, let's say, affects one person or a group of people, right? An AI system making the same decision affects thousands, maybe millions, maybe entire populations. So even a small bias becomes a large structural outcome. This is why AI bias matters more than the individual bias. It operates at a scale, it amplifies. Last but perhaps the most importantly is that why you should care about AI bias is because you're already using it. You're already interacting with these systems all day, every day, pretty much every moment of your waking hours. You don't need to be an engineer to be affected. If you apply for jobs, use social media, search online, interact with the platforms. You're already inside these systems. Your data, your input are already inside these systems. So the real question is not, do I use AI? It is actually, how is AI shaping what I see, what I get, or what I experience in the world, right? So this is all to say that you should care about AI bias because these systems are already making decisions around you, about you, and sometimes for you. And if you don't understand how they work, you can't question them, you can't challenge them, or you can help design them better. So now let's talk a little bit about how a very typical bias, a gender bias, sneaks into the AI models. There's a common misconception that the AI is a neutral mathematical black box that exists independently of human error. But if you look at the structural level from an engineering point of view, you will see that AI is a product of its time and organizational context and reflect the knowledge, the available materials, and the implicit biases of its creators. When we talk about gender bias in this context, we aren't just talking about feelings. We're talking about the systemic unfair differences in how a model processes and treats the data. So in the next couple of minutes, I want to talk and walk you through the sociotechnical framework. It's called the sociotechnical framework of this bias, and examine the data loops that amplify it and discuss the specific engineering protocols that we can use to mitigate it. So when we talk about biased AI, we aren't just talking about an abstract social concept, right? So research shows that AI is a product of its time and organizational context. That's what we just said. And essentially, technology is both structurally and socially constructed. And it mirrors the implicit biases of its creators and gain new functions, potentially new biases through repeated use in the loop. Research shows that gender bias, specifically in AI, is defined as systemic unfair differences in how men and women are treated within a particular domain. So as an engineer, I find this fascinating because algorithms are technically designed to discriminate. What do I mean by that? As an engineer, when I say the algorithms are designed to discriminate, I'm not using the word discriminate in its common social legal sense, which usually implies a prejudice or unfairness. Instead, I'm using it as a technical mathematical sense, the ability to distinguish between different cases or classes of data. So to a computer scientist or an engineer, an algorithm's primary job is to tell things apart. Here's the mathematical breakdown on what that means. Let's talk a little bit about the pattern separation. I've been in this space for a while, and I was one of those early researchers of semantic analysis and language models. And more than 10 years ago, when I was very deep in the weeds of my PhD working on these exact systems, my entire job was to build classifiers. When we use the word discriminate in the lab, we aren't talking about the social prejudice. We're talking about pattern separation. If you're building a computer vision model, for example, your algorithm must be able to discriminate between a chihuahua and a chocolate chip cookie. If it can't, the model has failed. If you're building a medical diagnostic tool, the stakes get much even higher. The system must discriminate between a tumor from a benign mole. Research shows that the gender bias in AI is defined as a systemic unfair differences, as we said. The algorithm doesn't know what is being unfair. It just thinks it's doing its job, it's looking for a feature or any feature that helps it tell category from category A from category B. Research shows that if you feed a classifier historical data that is 90% male, the machine concludes that being male is a high signal feature for success. To the AI, it's not being sexist, it's not being unfair, it's just trying to tell the cookie from the chihuahua. As engineers, we have to realize that our objective classifiers are actually high-speed mirrors of our own historical data patterns. So when we train an AI, we're essentially teaching it to create a decision boundary in a multi-dimensional space. That's ultimately what it is. The algorithm looks at thousands of features, which could be data points like age, income, education, pixel patterns, success, no success, you name it. It then calculates where the gap is between different groups. The discrimination, in the mathematical term, is an act of placing a data point on one side of that line or the other. That's simple. So where the engineering becomes a social problem, let's talk a little bit about that. The problem and the reason why it is fascinating from an engineering perspective is that the machine doesn't know the difference between a valid technical distinction and a harmful social bias. If you tell an algorithm to optimize for successful hires and give it to 20 years of data where only men were hired for an engineering role, then the algorithm mathematically concludes that being male is a highly signal feature for success. From the algorithm's perspective, it's doing its job. It's found a pattern that helps discriminate between a good resume and a bad resume based on the historical data that was given to it. Research shows that AI acts as an automated mirror, okay, but it takes subtle and very messy discrimination present in human society and turns it into a hard mathematical rule. So now we have covered the very nature of algorithms, specifically the type of algorithms used in the AI model, which is discrimination and prediction, inadvertently causes bias in AI. As we've discussed, these systems aren't thinking that they're deciding, okay, I'm going to be sexist algorithm today, right? They're sorting, they're classifying, and they're making inferences. The core engineering problem is that when these systems are trained on historical data with inherent biases, those prejudices are not just a noise anymore to the machine. They become part of the solution. And the AI sees the historical pattern of inequality and assumes that it's the optimized path forward. And research shows that this is not a technical glitch, or is not a sociotechnical phenomenon where the code and the context are inseparable. You see how you begin to see the bias problem like an engineer through the eyes of an engineer? Now that we understand the why, we're going to look at the specific mechanisms of how this happens in the real world, and from recruitment to facial recognition, and most importantly, how we as engineers, or you, someone who's interested in the societal context of AI bias, can actually contribute to fixing it. To understand how a machine learns to be biased, we have to look at the three main pillars identified in the research, which is data, design, and society. First, let's look at the data. Research shows that the gender bias in AI can be attributed almost equally to the algorithmic design and the training data sets themselves. If the training data lacks female representation or contains historical prejudices, the AI will internalize those as ground truth. For example, research shows that many AI applications had to be withdrawn because they were trained on datasets with inherent gender biases. This creates a self-training loop where the AI continues to learn from its own biased outcomes, making the problem even worse over time. The second pillar is design. Research shows that the predictive algorithms are developed predominantly by men. This is where the engineering perspective is vital. Human involvement in selecting the features and models for an algorithm is inherently subjective. If the development team is not demographically diverse, they may inadvertently program in socially acceptable inferences that conflicts with the fairness requirements. And finally, we have the social pillar. Research shows that the AI doesn't just reflect the society, it amplifies it. In fact, the most common social consequences of AI, an AI bias, is the amplification of existing bias, which research shown that occurs in pretty much 28% of the studied cases when a bias system is used at scale, like in the recruitment case, it turns individual human prejudice into systemic automated laws. Let's move into the empirical evidence. Research shows that some of the most advanced AI implementations in the world have failed specifically due to the gender bias. A prime example in the AI bias, resume services used by companies like Amazon and LinkedIn. Research shows that these systems were trained on a decade's worth of resumes that were predominantly for men. Because of this, AI taught itself that technical success was a male trait. It began to actively penalize resumes that included the word women's or women's chess club and stopped sending IT job openings to female candidates. We see the same mechanism in image-based AI. Research shows that a recent study which proved that advertising algorithms demonstrate sexist tendencies when targeting marketing. From an engineering standpoint, these biases manifest differently depending on the input. In natural language processing like text, research shows that bias often hides in word embeddings, where the machine calculates mathematical distances between concepts. Whereas in computer vision like images, research shows that the bias emerges in deep representations, often because of the datasets simply don't have enough diverse examples of women in various contexts. Now, how do engineers actually contribute to a solution? The research shows that this is not just an algorithmic problem that can be fixed with a single line of code. It requires a sociotechnical intervention. Research shows that the most effective solutions are concentrated on the design phase. Specifically, improving diversity in AI development teams is cited as a solution in 30% of the literature. That is huge. By having a diverse team, you bring different subjective lenses to the future selection process, catching potential biases before they are hard-coded. And beyond diversity, research shows that the human-in-the-loop protocols are essential. In about 23% of the cases, researchers found that keeping a human actively involved in the final decision-making process allows us to adjust and override the biased outputs of an AI. We also need to integrate ethics directly to the design process so we can make fairness a non-functional requirement, just like security or latency. Finally, research shows that we need to build an ecosystem of trust. This involves collaborative ethical AI platforms where stakeholders can share knowledge and strategies for fairness. It also means creating public policies that ensure AI systems comply with fundamental human and consumer rights. So to wrap this up, we have to recognize that AI is essentially an automated mirror of us. If we feed it with a history of bias, it will give us a future with an amplified inequality. But as an engineering professor, I see this as a call to action. Research shows that while AI can echo and amplify human bias, it also plays a critical role in identifying and reversing those same effects. We have the unique opportunity to use these algorithms to uncover prejudices that were previously invisible to us. Our contribution as engineers is to move away from the neutral tool myth and acknowledge that we're the architects of social outcomes. We're the designers. We contribute by being rigorous with our data, by auditing our models, and ensuring the diversity is a core component of our development life cycle. The goal is not just the machine that works or the algorithm that works. It's actually, our goal is to create a machine that works for everyone, for the good for the society. I'll see you in the next episode.